Welcome to I Just Don't Know, a podcast where we try to learn something new, challenge my opinions, and hope to make the misinformed informed. I can openly say I've spoken when I did not need to, been unnecessarily controversial, and shared my misinformed opinion, thinking it was not. I am Rod Clulo, and in this podcast I will try to right some wrongs, take on a new topic each episode that I think are new, but in fact I just don't know. This episode is about exploration of the unknown beyond our solar system. It is things that are beyond our imagination, space and time that we cannot even fathom. Some might argue that we can literally only speculate and just guess of what is out there in the dark depths of space. But in fact, there is clearly a community and a big part of the science world dedicated to exploring beyond our solar system. And that while we have a lot to learn on planet Earth and around the planets in our solar system, there is definitely curiosity about what is out there in what they call interstellar space, beyond the grasp of our sun and our solar system. So put on your spacesuits and gear up for a trip into the vacuum of space, out of the clutches of our sun, our star, and beyond our own planetary neighbourhood. So my assumption in this episode is that while I did study physics to AS level at school and have watched pretty much all of Brian Cox's documentaries on space on the BBC, and I've listened to the occasional podcast from someone from the scientific community about the solar system or the latest theories about black holes or string theory or something like that. And I say I would have a general understanding of the solar system with Venus, Jupiter, Mars, and Saturn, and Earth, and just generally understanding of the planets that are in our solar system, and that the universe is expanding from a center point that they call the Big Bang. The generally accepted theories of space and time. However, I actually realised that a lot of my knowledge is based on sort of quite old-fashioned or basic understanding of what I learnt at school. But that was a while ago now, and simple things like, well, was Pluto or is Pluto a planet? Why did it become a dwarf planet? Well, that's what I'm going to explore and realise that there's a lot that has developed since then, and that we've learnt so much about our solar system, but also that from the things like the Hubble telescope and some spacecrafts that have travelled across the length of pretty much the length of our solar system and beyond that I wasn't aware of, that we know so much more than we did when I was at school. And there's less theory, more actual potential evidence of things like distance and time, and an understanding that our solar system has a history that we didn't even realize. So while I understand that what I know is quite basic, what I'm trying to do in this episode is prove that actually there's quite a lot there that I didn't know about, and that a lot of people potentially don't know about, that we've learned from these epic missions over the last 30-40 years that just take time to get the results and get the information. So listen up, I hope you enjoy, and let's see what we can discover beyond our solar system. So this episode was actually inspired by a TV series that hopefully some of you know about. It's called The Expanse. It's on Amazon Prime, and it's a really interesting TV drama that's completely fictional, sci-fi, based in the future. But it's on to its last and final season that I finished now, and it's based on the books by James S.A. Corey and it's all about how humanity has colonized our solar system, and that it does follow sort of a storyline of these protagonists, a group of people that come together from different backgrounds. So that's a classic story. But the overall summary of the Expanse, if you don't know, is that you have Earth that has developed into a United Nations. Everyone is together. Food shortages have left people having to unite and work together. But there's also been a colonization of Mars, and that is actually broken away from the Earth, and the Mars Republic, or if I get the Mars Republic has taken on a very long-term effort to terraform Mars and turn it into a forest, bring greenery back to sort of the barren planet that is Mars. But they've become quite a military-driven nation, and there is a rivalry there between Mars and Earth. But also, to add another faction into the whole story, is that there's these, and this is where this will go further in this episode, is that there's the Belters, as they call them, and those are the people that were born and lived and died in space, and these are the people that have colonized things like the moons of Saturn, the moons of Jupiter. The belt is, in terms of the Kuiper Belt on the outskirts of the solar system, a ring of asteroids on the far reaches of the solar system, but also a ring of asteroids between Jupiter and Mars as well, and these space stations that have been built to mine these huge rocks and all the minerals that are including. But there's a massive division there between the Belters and Mars and Earth. The Belters are treated they are treated as slaves and second citizens, pretty much. So, really interesting series that I highly recommend. They do try to stick to the physics and try to stick to the truth of what is could have happened. For example, those that are born in zero gravity in the space stations, the Belters, if they're on Earth, it is incredibly painful for them because they've got used to zero gravity or very little gravity or artificial gravity, whereas Earth, the pull of gravity is so strong, it's actually painful, and they use it actually as torture in the first season when they find some Belter spies. So it's pretty brutal, but using physics to make an impact. And how the story develops is that eventually Earth and Mars sort of fight it out, and the conflict sort of occurs, and it's terrible for both sides, influenced by an introduction of sort of an alien particle species. But then the Belters actually unite, and they become very tribal. It's almost reminiscent of sort of the pirates in the Caribbean, with different sort of groups of ships pillaging and sacking other ships that they find on their own. Eventually the Belt unites, as I said, and fights back and sends rocks towards Earth. But there, I don't want to ruin too much about the story, but overall it really gets you thinking about how potentially we could in the future, or if we discover a way of traveling to the speed that they do in this show. And I think in sort of season 3 or 4, they talk about the person who managed to discover the engine or the power core that allows people to travel to that speed, those speeds. But really interesting, it's things like momentum in space, that obviously it's a vacuum, so there's nothing slowing you down, so you have to really control your speed differently to the way you'd expect in, let's say, driving a car on Earth, where friction will slowly make your car come to a stop if you stop accelerating, stop putting the pedal on the gas. It's just a completely different world, and they really stick to it well in the show. So if you're a fan of the physics, especially physics in space and things like that, it's really interesting. And that takes me on sort of great into the idea of if we were setting up a space station or colonizing a moon in our solar system, but even beyond in terms of the asteroid belt, the the idea of actually making artificial gravity and therefore allowing things to grow and humans to exist. And what they do actually in the show, and you see in the first sort of massive station that they've built, Ceres Station, which is named after Ceres, which is a moon, is one of the largest moons in. It's a dwarf planet. It's one of the largest moons in between the orbits of Mars and Jupiter. So in that sort of first belt of asteroids in our solar system, and I'll come on to that later about how the solar system is set up that I didn't even realise. So I didn't know that there was a belt of asteroids between Mars and Jupiter, and then again further out where Pluto is. But Ceres is a dwarf planet, and it's part of the sort of asteroid belt, as I said. And what they do in this show is they create it. They've got a station that's called Ceres instead, and what the station does is that it rotates through nuclear power. Two nuclear sort of power stations make it one with a backup that make it sort of rotate, and by rotating in a sort of a circle, it creates that centrifugal force and that artificial gravity, allowing some form of gravity to exist, and therefore there is capabilities of growing crops. But even more interesting, what they actually show in the Expanse is if you are in zero gravity and you injure yourself and you hurt yourself, your body doesn't or isn't able to send sort of the necessary white blood cells and support to the wound for it to heal in a normal, traditional way. It takes too long, and therefore you will bleed out or not repair yourself properly. And therefore you have to have these special machines that they've created that they don't explain the science, unfortunately, but they do highlight that if someone is injured or broken leg or broken arm in zero gravity or in artificial gravity potentially, they need to get to a planet or, as I said, artificial gravity, to allow the healing process to begin. So again, they go really into the detail of the physics, and that's why artificial gravity would be so important. And this idea of a rotating space station would actually make it doable, potentially viable for humans to exist out in the outskirts of our solar system, away from any large planet, but within reach of the sun. So that got me thinking about the belt and the asteroid belt between Mars and Jupiter, but also beyond that, what is called as the Kuiper Belt. And while I was obviously taught about, as you might have done, is being taught about the planets of our solar system, but what is actually sort of beyond that? And I've heard of the Kuiper Belt in the past, but I didn't really know what it was, and we're going to look into that in a bit more detail. But what is really interesting is that I wasn't really aware of the missions that were sent through our solar system, but with a plan to actually go beyond our solar system and discover what might be beyond. So it starts off with in the 60s, a guy called Michael Minovich did, while on a summer job at a jet propulsion lab in the US, he found that at certain points in time, the planets in the solar system were aligned that allowed gravitational pull of each planet to slingshot a satellite, space probe, whatever you want to call it, through our solar system, the neighbourhood of our planets, to the edge of the solar system. Traditionally, sending it in a direct line would take too long, but by using the planet's gravitational pull, slingshotting it from planet to planet, this is doable, and it's amazing. This guy, Michael Minovich, wrote a paper called The Invention of Gravity-Propelled Interplanetary Space Travel in 1965 on a summer job. Imagine doing that, but that's pretty epic. But in the 60s, the moon mission to the moon, space program, NASA was at its height, and there's a huge amount of funding going on behind it to make sure we stayed ahead of the Soviet Union. And so it doesn't surprise me that this person was inspired to look at this and wrote this paper. And this was the basis of two missions that were set up in the 70s. The first one is Voyager 1, and the second one is Voyager 2. So Voyager 1 was a space probe launched by NASA in 1977 as part of the Voyager program, and 16 days later, its twin Voyager 2 was launched as well. So the Voyager 1 was operated for 44 years, 5 months and 11 days, and is still going, supposedly, into interstellar space. But I've ruined it there a little bit for you. But let's look at the background. So it's the first one was 800 kg and worked on by NASA by 150 engineers, scientists, costing over $250 million. That's probably more than $1 billion now. Originally, Voyager 1's mission was to explore Saturn and the Jupiter systems, to sort of take pictures of the rings of Saturn and understand the gas giant Jupiter. It also had a golden record attached to it, which had information about the humankind on Earth at the time in the 70s, a time capsule, just in case any intelligent life forms came across the probe. The mission and the construction went flawlessly, actually, and there was a great moment for space travel in general and for the US. It was obviously hijacked by the politicians, but it was a really important moment for the space travel community and the scientific community. And what it did, actually, Voyager 1, was that when it was 6 billion kilometers away, it turned around. For the first time, it turned off all its instruments to take pictures. And it actually took a picture of Earth, our first ever self-portrait. A little green and blue dot that was sent back to us, and it was the first time we'd ever taken a picture of Earth. And while you can Google now a picture of Earth and it's been CGI'd and it seems like we've taken thousands and thousands of pictures of Earth, that was the first one taken from a very long way away. But it's a self-portrait of where we're from and where we all exist. So when it carried on going and it managed to sort of take pictures of Saturn, and it did flybys of Jupiter and Saturn, and also the largest moon, Titan. And they apparently had a choice though. They could have gone towards Pluto, or they could have gone via Titan, Saturn's largest moon. And in the end, they chose to go via Titan. And what they actually did, it's really interesting, is that when they went beyond, they took these epic pictures of the belt of the rings of Saturn, and is that in order to manage it and keep managing the sort of energy and the power of the probe, and being allowed to still take measurements and send information back to Earth, the most challenging aspect was to keep energy so that it could make sure the entrance didn't get too cold. And while it did have the heat of the sun, it's becoming less and less and less. So in terms of the setup of the solar system, especially on the edge, you have the control of the sun, or the heat of the sun, and then you have and that takes you all the way to sort of the Kuiper Belt as such. But then you have something called the Hedosphere. And that is basically the atmospheric layer of the sun that is larger than what the sort of is beyond the sort of immediate control of the sun, but it's like bigger. So imagine sort of a raindrop falling to the ground, and sort of in the bottom part of the raindrop, in the very center is the sun, and in a small sort of circular shape, in a sort of sphere shape, you have our sort of immediate solar system, and on the edge of that sphere you have the Kuiper Belt and sort of big ring of asteroids and rocks that is supposedly feeds the different sort of asteroids and comets that enter the solar system. But beyond that, you have something called the Hedosphere, that is the rest of the raindrop, and because it creates that shape of almost like that sort of raindrop shape with sort of a tail and a head, and with the solar system sort of right in the middle of that head. And that's because if you move it sideways, the galaxy is moving at a humongous speed around the center of our galaxy, the Milky Way galaxy. Like going around, imagine a solar system in itself, we're going around in circles. And therefore, and arguably we are accelerating as well with expansion of the universe as well. And that creates almost like a trail, a speed trail, like you're driving in a direction. And so this larger part, the rest of the raindrop, is that shape, and it's called the Hedosphere. It is influenced by the sun, and we're not sure exactly how much is influenced by the sun, and I'll come on to that in a second about what Voyager 1 discovered, and also Voyager 2. But what it is doing is going into something called the bow shock, which is the influence of other stars ahead of us that we're hitting. As with you cycling into or driving into along a road, you're hitting sort of wind. There is some sort of something in your way, and therefore you're having to displace that, push that out of the way, and it's the same thing. And therefore that's what it's also pushing on us, creating that drag effect and creating that shape. And that's what the Hedosphere sort of looks like. But what Voyager 1 did pick up is that when it did leave that sort of the sort of immediate sphere of our solar system, is that there was a change in particles measured on the instruments, and they weren't 100% sure if this was accurate because they had only had one reading, but there was an increase in charged particles from another source, not from our sun. And there was the charged particles from the sun were measured consistently, so they know what that looks like, but there was a clear change. And these different charged particles are from exploding stars and supernovas in different sort of galaxies, and they saw a dropout on the 25th of August 2012, so sort of 40 years after, and the particles measured were flipped and stayed. And there was an argument that perhaps was the plasma instrument not working, but they were pretty sure it was working. But what actually, and this is where science is so interesting, they weren't sure if this was the case, and they couldn't be sure. But what actually happened is that there was a solar flare recorded in our sun, and then 13 months later, it was picked up on the Voyager 1, a spike in particles that we can associate with our sun, proving that Voyager 1 was definitely out of our solar system and into interstellar space within the heliosphere. And this is just conclusive that it was picking up the plasma instrument was definitely picking up more particles from other suns than our own, and proving that it had definitely left the outskirts and left our solar system, the first probe to leave our solar system. And it's pretty a testament to the engineers that built Voyager 1, that it's the fact it's still going. And it says here that the Voyager team tested their spacecraft's trajectory correction maneuver in late 2017, the first time they'd used the thruster since 1980. A project enabling the mission to be extended by 2 to 3 years. Voyager's 1 extended mission is expected to continue until 2025, when its radioisotope thermoelectric generators will no longer supply enough electrical power to operate its scientific instruments. It's still going until 2025. And What was really interesting though is that Voyager 2, with Voyager 2 though, is it was launched at a very similar time and saw similar sort of same sort of success. Voyager 2 also remains in contact with Earth and is set out to carry on into the far reaches of beyond our solar system as well. So they not only did make one space probe, but they made two, and that is pretty cool. So what Voyager 2 does, and it also remains in contact with Earth and NASA's Deep Space Network, as they call it, and they very smartly maintain the energy to keep all the instruments warm. But what Voyager 2 did is that they managed to take a picture and go across and cover the Uranus and the Neptune systems in the late 80s for the first time. And so they've managed to tick the boxes of our current solar system, but what I find is really impressive is that they've managed to go beyond what there is expected and have a mission in itself into interstellar space. On the internet, you will see if you go on the NASA or the Jet Propulsion Laboratory, you can actually go and see where Voyager 1 is estimated to be, or the distance from Earth. So currently it's going very quickly. Voyager 1's distance from Earth is 155.79 AU, and we'll come on to AU in another episode, but that is effectively the distance between the Sun and the Earth, and so that is around 14 billion miles, and 14.5 billion miles. And Voyager 1 distance from the Sun is so it's a little bit more than that. It is about 21 hours, just under one light time away, which I don't quite understand that one. But then Voyager 2 is 130 AU, so distance from the Earth and Sun. It's about 12 billion miles away. So they're still going, and they call it the cosmic ray data. And there's a little green bar showing how much they're getting from the Sun and how much they're getting from interstellar space. So it's super, super crazy how far away they are now, and they keep going. And then this comes on to a really interesting topic to sort of round this off about sort of the Voyager 1 and Voyager 2 before we come on to some other space probes that I want to talk about, is that how does this help in asking the question about what is beyond our solar system in terms of alien life? And so in 2040, someone writes, the US will be in a very different place, as you can imagine. And the world will be very different. We will perhaps be on solely nuclear power. We won't be using nuclear power. He says here Prince George will be 27 years old, potentially in line to be king of Great Britain soon. But overall, we need to look at what does this mean in terms of space travel and things like that. So let's start off with the number of stars in our galaxy. So conservatively estimated at 100 billion stars in our galaxy. And of those 100 billion, 20 to 50% probably harbour planetary systems. So they look like similar sort of to the solar system that we know. And there is an estimate that has become more and more reliable because of the Kepler Space Telescope and ground observation, that there is an increasing number of something called the exoplanets. And that starts with, this all goes back to 1961, where the National Radio Astronomy Observatory in Green Bank, that a guy called Drake developed a sort of a now famous Drake equation, which calculates how many advanced and detectable civilizations there should be in the Milky Way in any one year. And this number actually turns out to be quite large, and it is based on the number of Earth-centric suppositions. And of course, civilizations can collapse and come and go and exist at different times, but basically it's a prediction of how many exoplanets, planets that are like Earth, potentially exist. So not all of these exoplanets are capable of sustaining Earth-like life, but Drake's equation estimates that 1 in 5 in the system could, and the biofriendly worlds from 0% to 100% would actually go on to develop life. In turn, there has to be some form of percentage chance that there will be some form of life on one of these exoplanets, and then within this life, there has to be some form of percentage chance that this life will be intelligent. So, the mere existence of intelligent life form tells us nothing, however, unless they have the ability to make themselves known and manipulate radio waves and any form of electromagnetic signalling. And Drake's equation estimates that 10 to 20% smart civilization would be able to achieve this. Obviously, with ourselves, humans have been around for 10,000, 50,000 years, potentially longer, but it's in such a small fraction of that time that we've been able to manipulate electromagnetic waves and radio waves and communicate in that sense. So it's like sort of trying to catch someone when there's the chance of seeing each other at the same time is very slim, you could argue. So how long would it take for these civilizations to blink their signals our way? So our sun should survive 10 billion years, and life on Earth has been around for about 3.5 billion years, and radio, as I said, humans have been around with radio wave capability for a couple hundred years perhaps. If we don't survive very long, our signal will go dark, and that is the unfortunate situation. But if we survive for another 10,000 years, we will be presenting our presence in the galaxy and beyond our solar system for much longer, won't we? So the chances of that actually crossing paths with a similar civilization in Milky Way will increase. So factor all this together and add in a bit of guesstimation and as they call it, statistical seasoning, as they describe it here, is that the results or possibilities will vary a lot. There might be 1,000 detectable civilizations out there at any given time, and if we be quite open, it could be more than that. It could be hundreds of millions. And imagine if there's around 10,000 civilizations that are detectable at any one point. That means we should detect life at some point. So to recap on that, so factor on all this together, stir in a little statistical seasoning. If you play the game conservatively, lowballing all the variables, you might get about 1,000 detectable civilizations out there at any given time. And be more liberal, you get hundreds of millions. The interactive lets you play the game yourself. Imagine there are 10,000 detectable civilizations, and we are likely to find alien life by 2040. If there are 1 million, we discover alien life by 2028. That is using sheer statistics. So, how do we figure this out? Well, astronomers look for alien signals, have examined only a few thousand star systems so far. But at the rate at which researchers are able to process the massive amounts of data that radio telescopes receive doubles approximately every 18 months or 2 years, meaning it grows by a factor of 10 every 6 years or so. The Milky Way has around 100 billion stars systems that conceivably host intelligent life. Under these assumptions, an estimate of 100,000 active civilizations in the galaxy would mean 1 per million star systems, At the exponential rate of growth in signal processing, researchers will have examined 1 million candidates by around 2034, bringing the odds of discovery into the probable. Adding or removing 0 from the estimate, the number of civilizations out there will merely add or subtract 6 years from the estimate, respectively. Since that's how long it takes to expand our search proportionally. So see you in 2040, aliens. So to go down on that again, basically, it's not an issue of is there Earth or aliens out there. It's actually sheer time that it takes to process what we're receiving from other planets. And that if we are improving our ability to absorb this information and review it and process the signals that we are receiving every 2 years and increasing by a factor of 10 every 6 to 7 years, we'll be able to process that. And it's, as it says there, the odds of a civilization existing is 1 in a million. Well, we should have processed 1 million candidates, exoplanets, by 2034. So the chances actually become probable, 1 in a million. If it doesn't, of course, we might have to do it more. It's only odds. It's like rolling a dice. You don't always get a 6 every time you roll the dice 6 times. But the fact it becomes probable means that either or, even if there's less civilizations out there than we hope, well, there's a chance, according to this methodology, that either in 2034 or sometime between 2034 and 2040, we should really detect some form of intelligent civilization. So that's in 15 years' time, roughly, a bit more than that, a bit less than that. So let's see if we do meet or hear anything. To finish off this then, so my assumption at the beginning was that I had this general understanding of the different planets from Mercury to Pluto. When I grew up, Pluto was a planet. I understood those are the planets you built your sort of scientific experiments with the different sizes of Jupiter and Saturn with the rings and cold sort of blue Neptune, and there was a general assumption of that is what the solar system, all coming from a central point of the Big Bang. These general understandings of physics from school, momentum, no gravity, but my knowledge of what actually the scientific community had done over the years, in the last 30, 40 years, was fairly limited, because while they did it in the 70s, we've only actually really gained some great insights in the last 10 years, especially some really big. Most important one was about 10 years ago, which is that the Voyager 1, Voyager 2 have left our solar system and have entered the Hedosphere and the interstellar space, and that these incredible space probes that were built in the 70s by these incredible engineers with the technology that they had back then, these space probes are still going, and they are picking up using epic. So they've sent back these epic pictures of our planets, of Saturn, of Jupiter, through the 80s and 90s. But what is most interesting here is that they've gone, and they are still going, into interstellar space, where they will continue to pick up more information and send back until they potentially, or until they will eventually run out of power, nuclear power or sunlight, electromagnetic power, to keep their instruments warm, keep the whole thing going, and eventually they will go cold and no longer be active. But until that time, they're going to continue to be on the true frontier of humankind in the solar system, the world, the universe that we live in right now, in our sort of tiny little pocket of what we call the universe. So really interesting. Hope you enjoyed that, and I really hope that we discover more and as they enter into interstellar space. So please join me for more episodes on this. I'm going to look at other space probes that I didn't really know about and some of the incredible things they've done, and I hope you listen to that and really enjoy the fact that there is so much more to the sort of general teachings that we know about space, and we have so much more knowledge of potentially what is out there beyond just planet Earth that we talk about a lot. So it's a bit of a a time off from planet Earth. Let's look at the solar system beyond and try and think really, really big picture. Thanks so much, guys, for listening, and look forward to the next episode.